Exactly. So as we were saying, if you add these two, you are going to get 1584.108. Okay. 1584.108. Multiplying the stress in the copper tube. Okay. Which is equal to our 120 times 10 exponent 3. Okay. Or kilo. So from here, what do we have to do next? Smart students, we will still repeat this again before dividing so that at the end of the day, uh, their presentation can be hot, logical, and represented in a coherent way. So that is, this can now be written as what? Let's repeat this again before we divide. That is 1584. Yes. 0.108 multiplying hot the stress in the copper tube times what is equal to 120 times 10 exponent power 3. Let's repeat the same thing as we are saying. So the only thing we do now is that we can now divide. You see, so let's divide. Everybody pick your calculator. As I'm doing, you're also doing. Okay. Point what? 108. Exactly. You come and divide here to by the same amount. 15. You do the same thing to here to 1584.108. Okay. So quickly, you realize that this can take care of this. And at the end of the day, what are we left with? We are left with something very, very special. That is, this can now be written as our stress in our copper. Okay. The stress in the copper tube is now equal to, the stress in the copper tube is now equal to 120 times 10 exponent 3. Okay. Times 10 exponent 3 all over what? 1584.108. Okay, yes, exactly. So this is it. At the end of the day, we just have to punch and then we see the answer we are going to get. So everybody, let's all quickly punch this together. Okay. So this can be written as what? 120,000. Exactly. Let's quickly punch that together. Let's quickly punch that together. So let's quickly punch that together. And that is what? 120,000. Okay. 120,000 divided by 1584.108. So at the end of the day, we press equal to, and we are going to get what? 75 points. We are going to get 75. I think that was what we had over here. And we had what? 75.7524. Okay. Newton per millimeter squared. And that is so wonderful and beautiful. So we are going to get 75 points what? 7524. Okay. So finally we are going to say that what? Therefore, our stress, therefore, let me denote this with a different color pen. And that is therefore the stress in the copper tube is going to be equal to 70 what? 5.7524. Because it is stress, we have to add a unit. Newton per millimeter squared. Exactly. Exactly. Up to this point, I want to pick some few questions before we proceed. Is anyone having any question to ask, any contribution before we proceed? Okay, so now we have to now we know the answer for, let me say, the stress in the copper tube. We know that it is 75.7524. Okay. So let's just put that into what? Equation 5 to get the answer for what? The stress in the steel rod. Okay. Uh-huh. As simple as ABC. As simple as ABC. As simple as ABC. So let me denote here as what? And this calculation we did tediously was what? For the stress in the hot copper. Okay. Uh-huh. So we did that for hot stress, to find the stress in the hot copper tube. And we did it and we come and get it over here. Okay, so now we said that what? Finally, comma. Finally, we can say that from equation, or let me say from equation 5, finally from equation 5. So let's put that down. Finally, from equation 5. Okay, from equation 5, that told us that our stress, okay, in the steel is equal to what? 1 point 1.66666, 1.6667. Okay. Uh-huh. Uh Stress at sea. Okay, that is the stress in the copper tube. And this was our hot equation, hot 5. Okay. So let's not worry ourselves much. So this was what the equation 5 was all about. So we just put that into it and then we get our answer. We are good to go. So finally, we are saying that uh, therefore our stress in the hot steel rod is equal to what? 1.6667 multiplying hot the stress in hot copper. So we can now just put everything into it and we are good to go. Okay. So that is by substitution. We can put the value for the stress in the copper tubes over here to get our answer, as simple as ABC. So we had 75.75, and that is over here. We had what? We had 75.75. Okay. Uh-huh. So for safety reasons, for safety reasons, we are saying that but what, comma, and that is our stress. Okay, but comma, the stress in copper is equal to what? 75.75. 75.7524. Okay, 75.7524 Newton per hot millimeter squared. Exactly. 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 So finally, we can just put it into it and then we are good to go. So we are good to go. We are good to go. So that is our stress in the steel rod is going to be equal to 1.6667. Okay, multiplying hot 75.75. 75.7524. Okay, so let's quickly point this together. Let's quickly point this together and see the answer we are going to get. So let's point that together. I have a calculator over here. So that is 1.6667. Okay, 1.6667 times 75.7524. 75.7524 equal to 126. We are going to get 126.25652508, and that we just want 4 decimal places. So we are going to maintain 126.2565 Newton per millimeter squared. As simple as that. So our final answer is what? 126. Okay. Better still, I can denote this with a different color pen to finalize our answer. Okay. And that can be written as what? Therefore, our stress in the steel rod is equal to 126.2565. Okay. Newton per millimeter squared. Okay. To be more flexible or to be more learned, you can choose to also write this as this. Okay. And it is still the same thing. Exactly. So on this note, I continue to say that the laws of physics are the same for all observers in a uniform motion relative to one another. Let's compare our answers to the standard. Okay. Let's compare our answers to the standard. So you see, this is the answers we were getting. For the stress in copper, we had this answer. Okay. And also for the stress in the steel rod, we have this. For the stress in the copper tube, we had 75.7524 Newton per millimeter squared. And also for the stress in the steel rod, we had 126.2565 Newton per millimeter squared. So I want us to compare it to the standard. Then if we are right, we are good to go. So you see the answers we said we are supposed to get initially. The answers we said that we are supposed to get initially were what? For the stress in the steel rod, we are supposed to get 126.25 Newton per millimeter squared. Okay, 126.25 Newton per millimeter squared. And you see that is what we are getting over here. 126.25 Newton per millimeter. This answer has been short to just 2 decimal places, but we have still continued to write 4 decimal places, and that is so wonderful. Okay. Also, for the stress in the hollow copper, hollow copper tube, you realize that we we are supposed to get 75.78 Newton per millimeter squared, but we also had what? We further on to had 75.7524 Newton per millimeter squared, and it is just equal to what? The standard value. We say accuracy is the closeness of a what? A result to the what? Standard value. So at the end of the day, you realize that we are very, very, very much what? Accuracy. On this note, I continue to say that the laws of physics are the same for all observers in a uniform motion relative to one another. Relative to one another. Relative to one another. Please, do you have any question to ask before we wrap up for the class today? Hello? Please, is anyone having any question to ask, any contribution to add up to whatever we have learned today? All right. So I will continue to say that time appears to pass slowly for a body in motion relative to the observer. Okay, time appears to pass slowly for a body in motion relative to the observer. Time is not on our side. You think that time is not moving, so oh, you can be reluctant, you can be procrastinating things. Don't do things that way. It's either now or never. You are either flying now or never. If you don't do it now, you may not be able to do it again. Okay, so we as observers watching you from a distance, we can say that time is actually moving fast, but you are saying it as it is moving slow for you. Okay, it is never moving slow. The time is moving. So you have to get busy with your books. Whatever we have learned, watch the video over and over and over and over and over and over again to build your understanding. Also, don't forget to subscribe to my channel, like the video, and also ask more questions in the comment section. Share for more so that at the end of the day, we can be able to solve problems within the society. Don't forget to see me in person, in groups, in person, one-on-one, in case you have any challenges or you still wish to become more history, or you still wish to become more history. On this note, my name still remains Megabyte, the physicist. Thank you all.